Buenas tardes, señoras y caballeros. Good afternoon. My name's Dom Hunt from Concern Worldwide. I'm here to talk to you about aftershock forecasting, the result of a project collaboration between Concern and the University of Edinburgh. We have a representative from the University of Edinburgh here, seismologist Professor John McCluskey, on the science, and Concern has been working on the humanitarian decision making as a result of the aftershock forecasting work that we've done. So let me just quickly run through the science of aftershock forecasting. As you know, earthquakes cannot be predicted. But once an earthquake happens, then there are certain robust seismological laws which tend to be fairly accurate and that we can use them for forecasting using probabilities aftershocks. So we can determine the likelihood of aftershocks of different sizes happening within certain time boundaries, and we can also indicate where they are more likely to occur. We do this first of all using the Gutenberg-Richter law, which looks at the relationship between the magnitude and the total number of earthquakes. As you can see from the graph on the right-hand side, with data from Nepal in 2015, you get many more small aftershocks than large ones. And that if you put this onto a log scale, you can see that you get many more on the left-hand side, the smaller magnitude ones. We can draw a line through them. It's relatively predictable. And using that, we can start to predict the likelihood of some of the larger ones and start to understand how likely they would be. The other law that we use is the Omori law. The Omori law looks at the number of aftershocks and states that the number of aftershocks will decay through time. So you're going to get many more aftershocks immediately after an earthquake. As time goes by, the number of aftershocks will go down. You can see here on the graph on the right-hand side how the curve starts to level off. It's a cumulative number that we're looking at. So as the curve levels off, it means you're getting less and less aftershocks. And then 17 days after the initial earthquake in Nepal, we had a very large aftershock, magnitude 7.3, which created its own aftershock sequence, which is why you've got two curves on the graph. Okay? And then after a while, by the time you get to 40 or 50 days after the initial event, it's starting to really tail off and you're not getting that many more aftershocks at that point in time. We can also plot the density of aftershocks happening in an area, and we can express them on a map, as you can see there. And by using color, we can also look at this through time. So where the reds and the yellows are, that patch, which is just to the right of Kathmandu, you're getting many more aftershocks happening there than you are in other parts of the country. Now, what that indicates is that that is the most active part of the country. So we can use that. This is a historical thing, but we can use that to say it's most likely that given that that area is active, that we're probably going to get more aftershocks coming from there. So we can put all of this information together, and we can get the seismologists from the University of Edinburgh telling us where they are most likely to be concentrated, as it says here at the bottom, an area 50 to 100 kilometers radius from the 7.3 epicenter, which is that area of the reds and yellows on the right-hand side. And we can also have this table of probabilities. So what this table is showing us is the likelihood of aftershocks of different magnitudes in the coming 30 days. Okay? And you can see, if you look at the M6, that we've got a probability of 69%, but taking into account error, that it could be as bad as 100%. So it's very, very likely that you're going to get aftershocks of a magnitude 6. Magnitude 7 is between 10% and nearly 24%. And again, that's fairly likely that we're going to get these aftershocks. We may even get aftershocks as large as 8.5, which would be larger than the initial quake. There's nothing to stop you getting an aftershock bigger than the initial main quake. That can happen. So we were told by our seismologists in Edinburgh, we were told we should expect aftershocks that are up to a magnitude 6. We might get aftershocks up to a magnitude 7.5. This is roughly as large as the initial quake. We know how damaging that was, and slightly larger than the large aftershock. So we received this information. We were out in the field responding to the emergency in concern. What we were doing, much like a lot of the other NGOs, working through a couple of partners, Rural Reconstruction Nepal and Nepal Water and Health, we were distributing 14,000 household kits. So we're talking about tarpaulin, sleeping equipment, hygiene items in a jerry can, and we were also reconstructing water supply and latrines. So fairly standard humanitarian response in the aftermath of an earthquake. Knowing that we were working, first of all, in the area which has been indicated as the most active in the country, okay, so we knew that we were very likely to get aftershocks where we were working. And also knowing that there is this pretty high level of risk and high likelihood of there being more damaging earthquakes. So first up, how do we use this information regarding the safety of all of our staff? In rural areas, we prohibited people from going into buildings, knowing that the buildings were unsafe, the likelihood of earthquakes was putting us at risk. Keep away from steep slopes. Make sure that you've got emergency gear with you or in your cars in case you get stuck behind a landslide. In urban areas where it's largely impossible to say that you can't go into buildings, so we were encouraging people to understand where to muster if you can evacuate from a building, or if you can't be downstairs and in evacuable area, to stay up on the rooftop so that if the building comes down, you're full with the building and hopefully live to tell the tale. And that we gave everybody whistles so that if you get caught under rubble, you can whistle. It's much easier to whistle than to shout. And also encouraging people to have a grab bag. Talking to the earthquake-affected population, you can see from the photograph that not all buildings fell down. I was actually in meetings where I heard people suggesting that it was time to encourage people to go back into buildings again because the monsoon is coming. And we knew that that would be encouraging people to go back into risk again. That we knew that there was this level of risk, the likelihood of earthquakes would come. So we were able to have the confidence to say, we don't actually agree, we think that you should stay outside. And we found that really important. We also used the information for better programming decisions. Some of the areas that we were responding to, you can only get there by walking up steep valleys with a very high landslide risk on the valleys, and that these areas we had to leave till last. The reason that you leave them till last is because the longer you wait, the less risk you are at of aftershocks. The chance of aftershocks will diminish through time. And immediately after a big aftershock is when you are most at risk, because then you are most likely to get more. So we were able to use that to plan our plan of action and to keep ourselves as safe as possible. We were also able to help people to understand the instability of slopes and to consider where they put their shelter. Ultimately, what I'm talking about is that the information that we got from the seismologists enabled us to be confident about the decisions that we make. Of course, there are some weaknesses, as always. One of the issues is around data collection. So the more data and the faster we collect the data, the better our forecasts will be. In Nepal, there is a decent seismological department that they are collecting the earthquake catalogue, and that we can use that to create these forecasts. But imagine if we had a big earthquake in somewhere like Afghanistan, where there is no seismological department, how would we deal with collecting the data that we need to do the forecasting? And secondly, the communication of risk, and we're talking about probabilities with uncertainty, and how do you communicate that to people? What we realized is that it's really important to be trained prior to an earthquake in the science and to understand probabilities and uncertainty, so that when you receive the information from the seismologist, you know what it means, and then you can act appropriately. And so that's where we're really going from here. We want to identify and we want to train decision makers who can use this information to make decisions about how to respond appropriately in the aftermath of an earthquake, bearing in mind that Concern Worldwide is a medium-sized NGO, our influence is somewhat limited, but it would be much, much better if we had the likes of UN OCHA, some of the bigger NGOs, some of the networks, national governments, seismological departments. If they were also receiving this training and receiving this understanding, then an entire humanitarian response would be influenced by the understanding of probabilities around aftershocks. And we also want to improve our ability to collect the data. So we're going to be looking at the use of mobile phones and the accelerometers to collect shake information, and also we're looking at whether we can deploy seismometers immediately after large earthquakes and do it that way. So there's a couple of options that we need to research. Coming back to the training, because we recognize how important it is to train people so that they understand, we are setting up an MSc in Science for Disaster Risk Reduction, which will be run through the University of Edinburgh, but it was a remote learning course. It's aimed at providing a core scientific knowledge of earth sciences, which, you know, what the science that underpins natural hazards, and that it's aimed at people who are not currently scientists. So we try and get non-scientists understanding the science. So in preparation at the moment is a PG Cert in solid earth hazards, which John is designing now, and that we are also planning to do a PG Cert in weather and climate hazards, and that these are going to be offered. We will also be offering bespoke training courses to senior decision makers in the humanitarian field so that they can also understand the probabilities when we release them in the aftermath of large earthquakes. So that's it for me. John and I will be here. If you want to talk more to us about the training opportunities or to understand more about the science, then we'll be lurking around here in the next half an hour or so. Please come and ask us questions. Thank you very much. Muchas gracias.